All right, good afternoon. It is Wednesday, January 22nd, and just embracing my last name with the chef's hat. I'm just kidding. All right, let's see if I have a joke. I do. Okay. Why didn't the quarter roll down the hill with the nickel? The quarter, 25 cents, nickel, 5 cents. It had more sense. Spelled differently, but pretty great, I think. Okay. Uh Let's get to some homework. All right, so this is homework lesson 10, solve problems with decimals. Um, we were still rounding. All right, we're still rounding and finding the place value and making sure that we have identified the place value. So here, if I wanted it to the nearest tenth, okay, today, if we rounded to the nearest tenth, this would be 3. I'm only looking at the 4. 4 isn't enough to bump it to the next 10th. Here, 2 isn't enough to bump it to the next 10th, but a couple things I've noticed. The 47 stays the same for everybody. And then I'm doing those kind of squiggly lines because it's an approximate answer. And then here, I was rounding to the 100th place, which means I'd underline that second number after. I saw something on someone's homework who had like 10th place, I think, or maybe it was it was Michelle's. It was her exit ticket, and then she had like 100th place. I thought that was really smart because then it reminds you it's like one place value. So shout out to you, Michelle. You're awesome. All right. Let's do some division. Okay. Let's find some multiples of 47, 14, 9, 94. 47, 11, 14, 141, 470, 47, 8, 8, 1, 88, and then 4, 7, 15, 13, 235. Okay. All right. So if I am doing this, sorry, I don't know what that was. I would be setting it up like this and then finding my partial quotients. I'm going to demonstrate for you the standard algorithm so that we can connect them. And I'm looking at 265 here. And so I'm looking at actually the 5 because 5 times 47 is 235. And then I'm going to subtract, bring that down, and then I have 300. So I'm going to try 237 235 plus 47, 282, and that's 6, right? 6, 282. I'm just keeping track of my multiples in case I have to go back. So now I've put 6 here. So first I divided, then I'm multiplying 6 times 47. Now I'm subtracting 8, 9, 1, and then bring down 8, and boom, there's a 4, 188. And then if I have 5, 6, 4 times 47, 28, 42, 43, 44, 35, 39, dust, 0, boom, boom. 4 times 4 is 16, 24, 25, 22, 8, 10, 15, 6, 2. Nice. Okay. All right. So let's get to some decimal stuff. Swimmer's top time for a 50-meter freestyle race was 22 and 93 hundredths seconds. Select all possible speeds that could have been rounded to the nearest hundredth and then getting 22 and 93 hundredths. So I'm underlining the hundredths place before I even move on because I don't want to forget. Okay. And then I'm looking to the right, and 5 is too high. It would go up here. Nice, just right. Here, 4, too low, not enough to bump it up. Here, 2, oh wait, rounded to the hundredths place. Oh, poop. I have done the wrong thing here. Oh no, I did. No, okay, yes, I'm right. Okay. And yeah, 5 is too big, 0 is good, 4 isn't big enough, 0 isn't big enough, it would stay at 2. That's already at 3, 2 doesn't need to be big enough. I'm circling that. And then it's at 2, which means it's in between 2/10 and 3/10. 5s gets it to the next tenths. That's great. All right. Um, I just want to demonstrate this. 22, 93, 935 thousandths. If I'm rounding to the nearest hundredth, this number is in between 22 and 93 hundredths and 22 and 94 hundredths. Okay. Now the 5 thousandths puts us halfway, which bumps us forward to the next hundredth. So that's why we're at not circling that first one. All right. You always want to know in between which two, numbers it is. Okay, the swim times for another race, the 100-meter butterfly, are listed below. Who won first place and who came in last? Explain or show your thinking. So let's see, first place, I'm looking for the shortest time, right? So the smallest time equals first because it's a race, right? And it's not distance or anything like that. So now I see two threes, and then I see Margaret at 400s, and then Michael has 300. So she came in first place, second place, and then I have four, and then Pablo came in third place. And in this case, Sarah came in last place. So my thinking is shown by recognizing the place values and yeah, Margaret, I'll say Margaret um, has the shortest time. So like she got in first. All right. Which swimmers have the same time when rounded to the nearest 10th? So I have two jobs. I have to round them to the nearest 10th, and then I have to decide about the same time. Okay. So it's round them to the nearest 10th. Again, underlining so don't forget. And if I have 55, it's going to stay 55. And then I have 3/10, and then I have 800ths. I don't need that. So the 800ths bumps me up to the next 10th. So that's going to be 4/10. I have 55 and 4/10, 700ths. I don't need the thousands. Seven is past, so it's going to bump me up to the next 10th. That's going to be 5/10. 55 stays the same. This must have been a really close race. I have 4/10, and then I have 800ths, which bumps me up to the next 10th. And then I have 55 is the same. 3/10. I have 400ths, and that keeps me at the same tenths because it's not big enough to bump. So which swimmers have the same time? Pablo and Sarah have 55 and 5/10 seconds when rounded to 10th place. Also, just really important to note how I'm, writing the seconds here and how I always rewrite the number ahead of time. It's just like really, really important. All right. What are the times of the swimmers rounded to the nearest hundredth? All right. So again, underlining so I don't lose track. All right, so here I'm doing my squiggly approximate lines. 55 stays the same. The 10th stays the same. And then I have 800ths, but 4,000ths. That's not enough to bump me to the next hundredth. So this stays. My 55 stays the same. So does my 4/10. And then I have 700ths and 4,000ths, not enough to bump me to the next hundredth. So it's going to stay. 55 stays the same. I have 4/10, and then I have 800ths, but then my thousandths is 5, and that's going to bump me to the next hundredth because it's half or more. Okay, 55 is the same, tenths is the same, and then I have 400ths, but 8,000, so that's going to bump me to the next hundredth. All right. There was a fifth swimmer in the race. What could the swimmer's time be if they had a time faster than Sarah, but slower than Pablo? Just go back to their original times. Sarah, 55.485, and Pablo, 55.474 thousandths seconds. So faster than Sarah Oh, because Sarah came in fourth place, right? That's what yeah. Sarah's in last place. Okay. So faster than Sarah, but slower than Pablo. So the fifth swimmer would obviously have to have 55, and he's going to be slower than Pablo. So that means that his time is going to be about Pablo's. And then if you look, there's about like 8 or 9 thousandths in between 474. I just want to show you 474 thousandths, 475, 476, 477, 78, 479, 470, nope, 480, 481, 482, 483, 484. So these numbers, this is Pablo, and then 485, 485 is Sarah. Okay, so these numbers indicate, and these are all 55 and okay, these numbers are all in between Pablo and Sarah. Okay. So you can pick any of these. Fifth person can have any of these scores because Sarah's is 55 and 485 thousandths. So four would be faster than Sarah, but slower than Pablo. Okay. So any of these times. This is Pablo and this is Sarah. Okay. Any of these. All right, name a decimal that makes each statement true. So something bigger than 24 and 80 hundredths and 24 and 79 hundredths. And I added the 0 for it to make sense. So I can have any number. I need it to be bigger than this. Well, this is already bigger than this. So this is okay. All right, 24 and 79.5. This is definitely bigger. And then 79.5 is bigger than that. But then we could actually have any of these in the middle, 24, 79, 1, 792, 24, and 793, all the way to 24 and 799, because that'll be greater than just this and less than this. Okay. Next, I have this would be 1,000. Okay, so has to be less than 5 and 100. So, okay, but greater than that. Okay, so it would be 5. I'm going to go with this, but I could also have this 98, 97. Notice I'm always filling out the rest of the number because that matters with the actual number. 0.954 and then 5.093. Awesome. And which number does the six, so any of these, obviously, which number does the six represent the hundredths place? Tens, tenths, thousands, C, hundredths, or as Nichelle does it, hundredths. Sorry, here we go, down here. All right. Have a wonderful night and see you tomorrow.